Now here's a problem that was given that tantalized me for a little while, because initially, right off the bat, I wanted to go to geometric means to solve this problem. And the problem being, you have a square side x with a 3, 4, 5 triangle inscribed within as such. And the problem is to find the area of the square, or in essence, really the side x, how long side x is. And so I tried many different ways, looking at the angle, knowing that this is 36.87 and this is 53.13, and then trying to find angles and such. And I finally gave up on it and went back to basics. And it took a little time. I didn't need to have a trick geometrically to solve this problem. I just went back to basics and said, well, what do I know? What do I know? Well, the area of the square is going to be x squared. And that's the area of the square. And I know one thing. I have an area of the triangle. I have this area here I'm going to call x, and I'm going to call area here area y, and this area here area z. And I know that the total area of the square, which is x squared, equals the sum of the area of the triangle, 3, 4, 5 triangle, plus the area x, plus the area y, plus the area z. And then I went algebraically to determine these. So what I did was I said, well, area x squared equals the area of the triangle. Well, the triangle is 1/2 the base, which is 4, times the height, which is 3. That's the area of that's a sub t. That's the area of the right triangle in the middle here, this 3, 4, 5 triangle. So that's 1/2 the base times the height. And that is 6. So I've got plus a sub x plus a sub y plus a sub z. So I have here x squared. I'm going to move this x inside so we don't get confused. X, and I'm going to give us a little more space to write. And okay, so I have x squared equals 6 plus ax. Well, ax is 1/2 the base times the height, so that's x. Darn it. X on 2 times L plus AY, which is m on 2 times q, and az is x on 2 times h. And I also know that q plus L equals x, and M plus H equals x. And I can use these in terms of substituting them into my expression here. So I have x squared equals 6 plus x, and L is x minus q, so I have x minus q on 2, and that is plus mq, so m is x minus h, and q is x minus L on, on 2 plus x on 2 times h. H is x minus m. Or maybe I just leave it h. I might just leave it h. But anyway, I then just carry out the math and try to eliminate things, get everything in terms of x. So I have x squared, x squared equals 6 plus x squared on 2 minus qx on 2 plus x squared on 2 minus x times h plus L on 2 plus HL on 2 plus, well, we'll leave this x on 2h for now, just for space sake. And let's see, that pretty much does it. We may have to change this term, but we'll look at it in a little bit. So here we got a grouping of x's, x squareds, and let's take a look at this. Well, let's see what happens if we plus HL on 2 plus, well, let's leave it like that, XH on 2. You know what, maybe what we'll do is this. We will use a clean sheet. That may be the best way to do it. Let's use a whole new sheet. You get the idea of what I'm doing here. This, we're just going to, we got x squared equals 6 plus x plus a y plus a z. And let's use a new sheet that has more space on it for us to write. Okay, so we have, just before I go away, we got Q, L, M, H. Everything is on the same terms. Okay. So we're just going to keep on this side here that x equals okay, so we have those three. We have 6x, which is x times L, M times Q, H times X, and 6. So now L, it could be that I got my terms wrong. So we have x times L. And L is x minus q on 2 plus 1/2 m on g. So m is x minus h, and q is x minus L. All right, so I got that. All right, everything so far is copacetic, plus 1/2 x times h, and h is x minus m. And then I have plus 6. All right, so those are the areas. So let's carry out the multiplications. We got x squared minus qx on 2 plus 1/2 x squared minus xl minus hx plus hl plus x squared on 2 minus mx on 2 plus 6. Now, a little more algebra. X squared on 2 minus qx on 2 plus x squared on 2 minus x times h plus L on 2 plus hl on 2 plus x squared on 2 minus mx on 2 plus 6. Alrighty, now we have 3/2 x, so that's minus x squared on 2 equals minus qx on 2 minus xh plus L on 2 plus HL on 2 minus mx on 2 plus 6. Let's multiply across. So we got x squared equals qx plus x times h plus L plus HL minus mx, or plus mx, and I made a mistake already. That's going to be minus, gotta be careful, and minus 12. So let's bring this over here, x squared plus 12 let's see, equals qx, so we got x times q plus h plus L plus m minus HL. And this gives us, now q plus L is x, q plus L is x, and h plus m is x minus HL. But HL, H equals, oh, what we didn't do here is this. Darn. One thing, very important thing I forgot. Okay, H equals 16 minus x squared, and L equals 25 minus x squared. And now we have 2x squared minus, okay, all right, equals 16 minus x squared times 25 minus x squared. And now we have x squared minus x squared plus 12 equals minus 16 times 25 minus 16 x squared minus 25 x squared plus x to the 4th. Okay, and now we need another sheet. Now we have everything in terms of x. Okay, that was my error. Okay, so I had minus x squared plus 12 equals minus 16 times 25 minus 16x squared minus 25x squared plus x to the fourth. And now we take a minus sign. We got x squared minus 12 equals all right, so we got this now. All right, 25 times 16 equals 400. And minus, okay, 16 plus 25 is 41. Plus x squared. If we square both sides, we got x squared minus 12 times x squared minus 12 equals 400 minus 41x squared plus x to the fourth. And now we got x to the fourth minus 12x squared minus 12x squared plus 144 equals 400 minus 41x squared plus x to the fourth. Now these go out. We have 41 minus 12 minus 12. So we have 29x squared on the left side minus 12, that's 17. So that's 17 x squared. Yeah, that's 41 minus, let's see, 41 minus 24. Yeah, 17x squared equals 400 minus 144, 400 minus 144, that's 256, and x squared equals, divided by 17, 15.0588235, and x equals, and that's the square root, 3.880, we'll round it off 6. And that's the answer. That's the answer to this whole big mess. That's what each side is. And that's the correct answer. And yeah, it was a bit of algebra, and you have to be careful, as you could see by my initial blunder. You have to be careful, but you could see that this works, and it's not too difficult. It didn't involve trigonometry. It didn't really, well, somewhat. It used the bare minimum of trigonometry. It used the Pythagorean theorem, and it used mostly algebra and just the basic knowledge that each of the, 4 triangles inside the square yield the area of the square. And so you just go straight forward from there, from what you know, and you have the solution. So that is my way of doing it. Now, if you go to the website from which this problem was taken, they use some kind of geometric trick that's not very obvious. And that's the problem. It's not obvious. So anyway, this is Math Man. Again, this problem was a little bug in my side because I was approaching it all wrong. But then I just finally used, well, what do I know? And everything kind of fell out. So the lesson to be learned from this is trust your instincts. Go with what you know, and it should lead you to the answer. Even if it may not be the cleverest way to go about it, it's certainly going to give you the chance to solve it correctly. And as you can see here, we did get the right answer for this. And going back to the original website or YouTube site from which I obtained this, it's Presh Math or something like that. He used some geometric trick that to me wasn't that tremendously obvious. He did solve it a little bit more quickly, but I think my method is a little bit more intuitive, a little bit more straightforward, even if it is longer. You just follow what you know and trust your knowledge, and if you do things carefully and correctly, it'll lead you into the right answer. Basically, what I tried to do, what ultimately I ended up doing is putting everything in terms of X. And we had enough information to be able to do that. So, again, Mathman wishing you well.